JANUAR.
Now, everyone, it's time to explore the mole, the sixth SI base quantity and a fundamental concept that plays a crucial role in chemistry. When we talk about the amount of a substance, what do we usually use to describe it? That's right, we use mass. In fact, this is something we've already learned about. We can describe the amount of a substance by its mass or volume. But is there another way besides mass and volume? That's right. Another way is to describe an amount by the number of atoms. If we keep dividing matter, we eventually reach atoms, the smallest units of matter. The simplest atom is hydrogen. A hydrogen atom consists of one proton and one electron, and it was formed at the beginning of the universe. However, most of an atom's mass comes from its proton. An electron has only about 1/840th the mass of a proton. Therefore, in chemistry, the mass of electrons is usually ignored, and only the masses of protons and neutrons are considered. A neutron is slightly heavier than a proton. However, the difference is so small that, in chemistry, their masses are usually considered equal. Ignoring electron mass and treating protons and neutrons as equal in mass, let's explore the mole, a way to count particles. Here's a sphere with a mass of 1 kilogram. In other words, each sphere has a mass of 1 kilogram. How can we express this scientifically? That's right. As shown on the left, the mass of one sphere is written as 1 kilogram per sphere. Notice that the number of spheres is in the denominator. Just as 1/10 can be written as 10 to the minus 1, the mass of one sphere can be written as 1 kilogram times sphere to the minus 1. Then how can we write 1 divided by 10 to the minus 1? That's right. Since it's the reciprocal of a reciprocal, it simply becomes 10. Likewise, 1 divided by sphere to the minus 1 simply means the number of spheres. Now, what happens if we divide 10 kilograms of spheres by the mass of one sphere? We already know that 10 kilograms corresponds to 10 1-kilogram spheres. So, dividing 10 kilograms by the mass of one sphere gives us 10 spheres. Now, think about what it means to divide 12 grams of carbon by the mass of one carbon atom. That is, the mass per atom. That's right. Just like the spheres, dividing 12 grams of carbon by the mass of a single carbon atom gives the total number of carbon atoms in 12 grams. The result is about 6.02 times 10 to the 23rd. This enormous number is called the Avogadro constant, and it defines 1 mole. Now we have the answer. 1 mole is the number of carbon atoms in 12 grams of carbon-12. This number is the Avogadro constant. Can you see the pattern? The sixth SI base quantity, the amount of substance, is also defined by the unchanging Avogadro constant. Now, the meaning of 1 mole is simple. 1 mole represents about 6.02 times 10 to the 23rd particles, and its unit is the mole.
Running through the light shells, K to M. K to M. Physics is the code, chemistry